Hello and welcome to Advanced Statistics and Analytics, fall of 2018. My name is Dr. Friedman, and this class will cover statistics, and I will talk about what is statistics in 2 seconds through my PowerPoint presentation. But before I get into what is statistics, what are we going to do, and what is the obscure thing that your professor will be obsessed with regard to the entire semester, open source R. Beforehand, I would like to go over the syllabus to make sure that everyone understands. We're going to have 3 textbooks in this class. The first textbook is my own textbook about statistics, and it was designed for information students, and I hope you will be able to enjoy it and to learn about that. The second aspect of the textbook that we will cover in this class is called The Art of R Programming, and it is basically why are we using R and what is the ability that R can give you as data scientist students, and why is it so important. The last book, as traditional in the open source R community, is going to be a free textbook that you'll be able to go over it, and this is the link that I gave I shared with you in the syllabus. I want you to just a note for yourself. Each textbook provides different perspective of the idea of what we're going to cover. I want you to make sure that you cover all three, because all of us give different things about statistics, and I want you to enjoy that or learn more about that. One of the things that I know that all of you are really concerned is grades. So how is it going to be in this class? First of all, personal blog is 5%. What does it mean, blog? A blog is where you're going to post your assignment, where you're going to review and be able to review other students in the class blog. So you will be able to share this experience with other users in this class, other students in the class. Then there's going to be a weekly assignment, which means that it's going to be tough on you. Why? Because we're going to learn about statistical analysis or methodology, but in the second part, you're going to apply open source R to implement this statistical methodology. For example, if we're going to learn about sample, you're going to learn how to apply that in R and how the result of it will be applied. This is where this textbook is a key component. You're going to have a major final project where you're going to select your own data and you're going to analyze it, and you're not going to do data mining or any other methodology. You're going to do statistical analysis. You can use, we will learn different frameworks, example descriptive, example predictive analytics, and you're going to apply that in order for you to conduct the final project. I will explain it throughout the semester, and I hope it will make more sense. I want you to look at the schedule and how it will play out, and if you have any questions, please do not hesitate to email me. My office hours are every Tuesdays between 10 and 4 o'clock in the afternoon in campus. Otherwise, you'll be able to catch me via Skype. If you never use Skype, you are welcome to use it. It's free, and so you'll be able to connect through your phone or your computer and talk to me face to face. And you can always email me. Okay, so this is my introduction to the syllabus, but now let's get started with the business of statistics and what are we going to do in this class. Okay, so the idea of statistics is to do better than average, and we will learn how to formulate formulas in order for us to calculate or to measure those ability to measure and to apply to it. So what is statistics? It is often defined as a group of methods that use to collect, analyze, present, but also to provide interpretation of data to help to make better decisions. And those are the things that we are going to learn in this class. So we will need, why do we need statistics? This is the often questions that students come to me and ask, why are we taking this class? So the idea here is that we are trying to evaluate, trying to understand why is it going in that direction or other direction. And a statistical analysis is basically an objective method that allowed us to observe what we learn and to able to conduct analysis that will give us some directions what is it means. In statistics, in basic statistics, we're talking about, and I'm sure that to the introduction class that you took about statistics, you covered descriptive statistics, and where you learn how to collect, summarize, and describe the data. Probably also you touched a little bit about inferential statistics, where we are taking the data based on sample. We try to make more sense out of the sample about the population, and we will cover that too. So in data descriptive statistics, we learn about collecting the data, presenting the data, and doing a standard statistical analysis such as standard deviation in order for us to make sense of it. Inferential, it's based on an idea that we take a sample of the population and we'll be able to test hypothesis in order for us to verify if our hypothesis is true or false. So the conclusion is based on the hypothesis testing that we are using in order for us to evaluate the population. But there is another aspect of statistics that we will cover in this class. In the end of the class, it's about predictive analytics. It's about time series, it's about modeling, it's about analytics in general. And I will talk about that throughout the semester, but in the end, I will focus on it. So I will start, the first two modules will be about descriptive statistics, so you will have a stronger understanding, because in the inferential and predictive analytics, you have to have strong foundation in descriptive statistics. So there is key definition that we have to understand in order for us to have a conversation. First of all, measurement. It is the key aspect of statistical research because it shows the relationship between the data and what it's been observed from the data. So we always measure things. A population is the universe that is the collection of all items or things under consideration. And this is really important because this is what is our foundation. A sample is a portion of the population that we are trying to examine in order for us to understand the entire population when we do not have the tools or the money to investigate the entire population. And the statistic is this measurement compute from the sample to describe the entire population, where we're going to focus in this class. So again, another way of looking at population versus sample. A sample is a small proportion of the population, but it has to have the characters of the population itself. So, example, every 10 years, the US government gather information of the entire population. Since the entire population is sample, it is referred to as census. So we are trying to measure who is the population in the United States, and it is always an issue when elections come. A sample is a process of selecting the element from the entire population. So the reason why we are taking a sample, it is less time consuming, it's less costly, and we can manipulate, or we can have some control how the sample works. There's two types of samples, non-probability and probability, and the item included are chosen with non-probability is without any procedure, without the probability knowing who we are going to select. And comparison in probability sample, we need to know exactly the probability that we are selecting from that group or other groups. And this is the breakdown of the type of sample used. So probability, simple random, systematic or cluster is part of the technique that we will cover in class. Non-probability is usually about convenience, about judgment, and we are not going to cover that in class, but it exists and it does have some say about what does it entail. So we will look at, again, the probability sample. We're going to learn it, and we're going to measure that in order for us to do more calculation about the entire population. In simple random sample, every individual of the item from the frame has an equal chance of being selected. The selection may be with a replacement or without a replacement, and the sample obtained from the table of random numbers or computer random number generator. It all depends your technique. Systematic is based on dividing the sample size, and we divide the frame of individual into groups in order for us to have better understanding. Example, first group that consists of n and capital N and small n and k, in order for us to select every k individual afterwards. Certified sample divide the population into two or more subgroups, and based on it, you will take a sample. So it's a little bit more complex procedure, but again, it allowed us to have a procedure that we need to follow in order for us to get the sample. Cluster sample is we divide the population into chunks, and we usually select those chunks based on a sample random that's been selected, and based on it we able to understand what does it entail. So there is advantage and disadvantage in samples. In simple random sample and systematic sample, it is really easy to use, but it may not be a good representation of the population under study. And this is something that I want you to keep in mind, because if in your final project you're going to conduct a sample, you need to select the right methodology that will represent not only part of the population, but the entire population. And this is something that you will need to spend some time in order for you to figure that out. Certified sample, it is sometimes hard to catch or to get and ensure representation of individual across the entire population. And this is really hard. And we can see it always in political sample when they have hard time to figure out who is the population. Cluster sample, it probably is the more cost efficient, but it's a less you need to have a larger sample in order for you to have the same precise level of precision in order for you to be successful. But we also need to talk about secondary or data source. Where's your data coming from? We usually in major of statistical textbook, we consider to have two types: primarily data collection and secondary. primarily is that we go out of our room and we observe, study, and do experimental work. Experimental is that we select people, we put them in a lab, and we test them and see what is the effect of it. Secondary is something that we often use in library science. We collect data from the library, or we collect data that is available on the web. It can be in print or electronic format, and based on it, we conduct our study. In type of data, we usually have two types. This is the standard. In this class, we will talk more about that, but this is the foundation. Because we are in module 1, I'm going to talk about 2. You will learn about much more, but for now, this is a good start. In the two type of data, we have categorical data and you have numerical data. Categorical data is, example, are you married? What is your political party identification? Or, easy one, what is the color of your eyes? So this is defined categories that allowed us to sort the data based on eye colors, or if you are married or not, or you have a bad haircut. In numerical, we have two types. Numerical means values. So we have discrete and continuous. In discrete, we have the number of children, and we have the fact per hour. In continuous, compared to discrete, we have weight or voltage. Weight, as you all know, we can gain weight because in the last 20 days, we ate ice cream all the time before the semester starts. So we probably gain weight. So it is always ongoing, and it's not steady as we expected. In compared to categorical data, that usually it's very steady and it can be classified for the long term. We have also level of measurements and measurement scale, and we will talk about that. We have normal data, we have ordinal data, interval data, and ratio. The ratio data is the highest level and probably the strongest form of measurements. And this is where we have the measurements of true zero exist. Interval data, we do not have the zero, and ordinal, we are sorting it based on category, ranking, order, or scale. And nominal data is again categorical, but without any order, without any idea. This is the lowest level, and sometimes we do not have a choice, and we have to work with nominal data. Most of the used terms in the textbooks, element of or numbers, elements. Element or a member is of a sample or population is a specific subject or object. For example, a person, a firm, a country. A variable is the second term that you're going to read in those two books and in any other forms of reading that you will be assigned in this class. A variable is a characteristic under study that assumes different value for different elements or members. For example, men versus female, age, income, education. The last element that you're going to hear me saying again and again, data set. It is the collection of observation on one or more variables that we collected. We are going to see different type of variables: quantitative variable, descriptive or continuous variable, and we will learn how to apply them. And we also have time series into it when we are doing cross-section data or time series data or any other type of analysis with regard to that type. So I want to end this part with, as you know, I am very fan of visualization and something that I will bring all the time. So this is from a character that from a textbook that was written by Shin Kandinsky, and she used characters to symbolize everything. So one of the things that she highlighted in the beginning cannot be measured, can be measured. When you look at data, there are always two types: data that you can measure and data that you cannot measure. And this is something that we will face throughout the semester. So I did not say where's my passion is, where I sit in the day and trying to figure out how to apply everything. So you probably learned in high school or in college about proprietary software such as Excel. And you need to have a license in order for you to use it, and you need to purchase it with your own money. This is the opposite of open source software. And so the movement of computer came to an understanding that yes, it's great that everyone is paying for the software, but there is a movement that I'm part of that see that that software needs to be free. And in order for us to do that, we are promoting or trying to promote the idea of open. For example, Mozilla or Firefox browser. It doesn't belong to any specific company. It belongs to open organization, and there is no CEO. There is no people that invest in the company, and this is the idea. So the idea is that it belongs to everyone who wants it. PHP is another programming language that often use open source. But again, we did not come to the idea of what is R. So to some people, R is the 18th letter of the alphabet. To others is the idea of the rating in your movies that saying you're allowed to see it or not allowed to see it. But R is much more than that. So this is where I am, this is my passion, this is where you're going to encounter throughout the semester. So in 1976, Bell Lab in New York started developing or to discuss the idea of S language. And what they try to do is to come up with an application that will give the ability to analyze the data. But Bell Lab was not a very successful company in the long run, and they had to close out and were purchased by AT&T. But in 1995, two professors from New Zealand purchased or tried to take the idea of the S language and to open its door to open source. So what they did was they created the R. Why did they use R? Is because their first name begins with R. Ross and Robert. So what is unique about R? It has two very important elements. One is that you write your own code, you run your own analysis, you need to write it in a programming language, which is R, and the ability that I'm very passionate about is the ability to apply visualization in order for you to do that. R is full of packages, which means that in a lot of situations, you will install a package that allowed you to apply more advanced statistical analysis than descriptive or use specific understanding. Example, in data mining, there is a lot of techniques. One of the techniques called Lotka's law. Lotka's law is the ability to sort publication based on popularity. So I created this package and I let everyone be able to access it and to adopt this. And there was some adaptation to it, but this is what I want you to learn. Learn how to use application or packages inside R. So what is R language? It is the idea of a programming language, and it is not like any other. It is like and unlike any other languages that has basic syntax, a structure that provide the ability a particular with a particular framework to work in order for you to have the ability to do the calculation. So the R is basically a statistical programming language that allowed us to do what we're going to do. What is a package? Is the ability to create your own package. If you have some ideas and you think that you are successful, if you look at that, you will see that there's a lot of there's a lot of packages, more than 14,000 packages, and each package provides us different options and different understanding. So visit this, try to understand what is it. I will talk more about that, and you will be assigned to read chapter 1 and 2 in this book about R, about the R programming. We also need to talk about two options how to run the R. There is the R console and the R Studio. The R console is the first application that was open. The R Studio is a latest development in the R community, and it gives you both the console and the ability to work on the web. So how to get started with the console? You download the console from the link that I provided, and it will install it, and it will not take a lot of space from your computer because it's basically a Unix programming language. It will look like something like that, but the thing is, you will need to type very closely in order for you to do the application. RStudio is a most recent development. It is applied to Apple and PC, and it's not a server, but it's application. So you download it to your own computer, and the interface will look at 4 windows: the code itself, the console, the output, and the packages and the workspace that you're going to do all those components. We will go over that quite closely and how to do that. This is the window where you're going to write your script. This is the console that was based on Unix, that where you're going to see your script actually in action. This is where you view your variable or the application out of it, and this is where you're going to see your files, your output, and everything else, and we will go over it. My hope that this short presentation give you some ideas of what we are going to do in this class and how we are going to approach it. The objective is that you, in the end of the class, you will have a strong foundation of what is data statistics is and what can you do with that. So my hope is that you are ready for this and you are ready for statistics. And again, let's have some fun with statistics. Until next time, enjoy your first week in school, and I will see you.